Protostar. A protostar is the very beginning of a star's life. It forms inside giant clouds of gas and dust called nebulae, where gravity slowly pulls material together into a dense, growing core. At first, the object does not produce light through nuclear fusion like a true star. Instead, it glows from heat created by pressure and collapsing gas. Over time, the center becomes hotter and denser until fusion finally begins. That moment marks the birth of a real star, main sequence star. Most stars in the universe spend the majority of their lives as main sequence stars. Our own sun is one of them. Inside these stars, hydrogen atoms fuse into helium, releasing enormous amounts of energy. The balance between outward pressure from fusion and inward pull from gravity keeps the star stable for millions or even billions of years. Smaller stars burn slowly and live much longer, while larger ones consume fuel at incredible speed. Red Dwarf. Red dwarfs are the smallest and coolest true stars known. They are dim compared to stars like the Sun, but they are also incredibly long-lived. Some may survive for trillions of years, far longer than the current age of the universe. Because they burn fuel so slowly, red dwarfs change very little over time. Astronomers believe they are the most common type of star in the Milky Way, quietly filling the galaxy in huge numbers. Yellow dwarf. A yellow dwarf is a medium-sized main sequence star like the Sun. Despite the name, these stars actually appear more white than yellow when viewed from space. They provide stable energy for billions of years, which gives planets time to form and, in some cases, support life. Yellow dwarfs are considered especially important in astronomy because they offer a balance between stability and brightness that larger or smaller stars often cannot maintain. Blue giant. Blue giants are massive, extremely hot stars that shine with intense blue-white light. Their high temperatures make them far brighter than stars like the Sun, but that brightness comes at a cost. They burn through their fuel very quickly and usually live only a few million years. In cosmic terms, that is a very short lifespan. These stars often form in active star-forming regions where huge amounts of gas are available. Red giant. A red giant appears when a star similar to the Sun begins running out of hydrogen in its core. The center contracts and heats up while the outer layers expand enormously. As the surface cools, the star takes on a reddish color. During this stage, the star becomes far larger than before. In the distant future, the Sun itself will expand into a red giant and may grow large enough to swallow the inner planets of the solar system. Supergiant. Supergiants are among the largest stars ever discovered. Some are so enormous that if placed where the Sun is, they would stretch far beyond the orbit of Mars or even Jupiter. These stars are unstable because of their size and energy output. They lose mass through powerful stellar winds and often end their lives in violent explosions. Famous stars like Betelgeuse belong to this category, giving astronomers a glimpse into the final stages of massive stellar evolution. White dwarf. A white dwarf is what remains after a smaller star finishes its life cycle. Once the outer layers drift away, the leftover core remains behind as a dense, Earth-sized object. Even though it no longer produces energy through fusion, it still glows from leftover heat. A spoonful of white dwarf material would weigh tons on Earth because the matter inside is packed together so tightly. Over immense stretches of time, these stars slowly cool and fade. Neutron Star. Neutron stars are created when massive stars collapse after exploding in supernovas. The pressure becomes so extreme that electrons and protons merge into neutrons, creating one of the densest objects in existence. Although only about the size of a city, a neutron star can contain more mass than the Sun. Some spin rapidly and emit beams of radiation, becoming pulsars that flash like cosmic lighthouses across space. Magnetar. Magnetars are a rare and extreme form of neutron star with unbelievably strong magnetic fields. Their magnetic power is so intense that it can distort atoms and release bursts of high-energy radiation. Magnetars are unstable and violent, making them some of the most mysterious objects in the universe. Variable star. Variable stars change in brightness over time. Some expand and contract naturally, causing their light to rise and fall in repeating cycles. Others vary because of eruptions or interactions with companion stars. These changes became extremely important to astronomy in the early 20th century. Certain variable stars allowed scientists to measure enormous cosmic distances, helping reveal the true scale of the universe. Wolf-Rayet Star. Wolf-Rayet stars are massive stars nearing the end of their lives. They are incredibly hot and blast powerful winds into space, stripping away their outer layers. Because of this, they often expose deeper elements like carbon and oxygen that are usually hidden inside stars. These objects are rare and short-lived, but they play a major role in enriching the universe with heavy elements that later become part of planets and future stars. Brown dwarf. Brown dwarfs exist in the strange boundary between planets and stars. They form like stars from collapsing gas clouds, but they never gain enough mass to sustain normal hydrogen fusion. Because of that, they are often called failed stars. Even so, they can still generate some heat and glow faintly in infrared light. Their discovery challenged older ideas about where planets end and stars begin. Quasi Star. A quasi star is a hypothetical type of giant object believed to have existed in the very early universe. Unlike normal stars, a quasi star may have formed around a growing black hole at its center. The outer layers behaved somewhat like a star, glowing from enormous heat and energy, while the core continued collapsing inward. These objects could have been millions of times more massive than the Sun, and may explain how supermassive black holes appeared so quickly after the universe began. Although no quasi-star has ever been directly observed, the idea helps astronomers understand one of the biggest mysteries in cosmic evolution.